Now let's look at this model of the stocks again. We're going to use U, D, and S for up, down, and the same. Instead of the P1 and P1 plus and all that stuff, let's use meaningful letters like we did for sane, borderline, and demented. Now if the probability, if given that you're up today, there's a 0.5 probability you'll be down tomorrow and a 0.25 probability that you'll be the same. This, of course, implies that there's a 0.25 probability that you'll remain up. If the probability, if you know for sure that you're down today, then there's a 25% chance you'll be up tomorrow and a 25% chance that you'll be the same tomorrow, leaving you a 50% chance that you'll be down again tomorrow. And if you're the same today, there's a 25% probability you go up and a 25% probability that you that you go down, and leaving a 50% probability that you remain the same. Then we get the following transition percentages. Okay, to get the number of up tomorrow, you take the 25% of the up, or the 25% probability that an up remains up. Remember that was from the fact that a 50% probability the up goes down and 25% that it stays the same, leaves us a 25% probability the up will contribute to up. And the 25% probability that a down goes up, because here's your down, 25% probability that it goes up, and a 25% probability that a same goes up. 25% probability here that a same goes up. That we have the 0.5 probability that an up goes down. We see here it is. And a 0.5 probability that a down stays down. That we get from the 0.5 and the 0.25. I'm sorry, from the 0.25 down that go up and the 0.25 down that stay the same, tells us that a 0.5 of the down will stay down. And a 0.25 that a down will go the same. 0.25 here, the down goes the same. And we can make similar interpretations on the last row. So that's the meaning of the model. And let's note also, while we still have this one up here, that the up breaks into the 50% that go down, the 25% that stay the same, and the 25% that goes stays the same, and the 25% that stays up. We see the 25% of the up that stays up right here, the 50% of the up that goes down here, the 25% of the up that stays the same here. This is everything that happens to up, so it has to add up to 100%. So that this column again has to add up to 1. Similarly, the 0.25, the 0.5, and the 0.25 are the probabilities that a down goes up, 0.25, a 0.5 that a down stays down, and a 0.25 that a down stays the same. And we can make similar interpretation on this column. In each case, the column represents the three probabilities that are related to the thing that we're looking at, the 0.25, the 0.25, and the 0.5. Okay, that's what we have here, the 2.25s and the 0.5. And we have the probabilities of where the same goes in this column. But those probabilities all have to add up to 1. Now we can put the model back into the P1, P2, P3 model. Here are the same numbers that we just had in the transition matrix. Instead of up, down, and same, we have P1, P2, and P3. When we multiply these out, this is of course what we get, and this is equal to our P1 plus, P2 plus, P3 plus. So P1 plus is equal to this, P2 plus is equal to this, P3 plus is equal to this. As an example, if we suppose that somehow we determine that there's a 50% probability that the market is up today and a 50% that it's down today and no chance that it's the same, then the probability it's going to be up tomorrow is what? Well, it's going to be 1/4 P1, 1/4 of the probability that it's up today, plus 1/4 of P2, 1/4 the probability that it's down today. And if we add that up, and then 1/4 of the probability that it's the same today, but that probability is 0. So we have our 1/4 by 1/2, and a 1/4 by 1/2, and a 1/4 by 0, gives us 1/8 and 1/8, or 1/4. Similarly, we find that P2 plus is 1/2 and P3 plus is 1/4. These numbers add up to 1. The column is the probabilities, and it has to add up to 1. And the column tomorrow then, if we multiply by a stochastic matrix, this one will also have to add up to 1.